Hello and welcome to GoGetterGeeks. I am Aditya Solye and this is our last video for code generator where we will implement the generic class creator logic. Let's dive straight into the code. So what I have done here is all the classes that I demonstrated in the last video, I have copy pasted all those concrete classes here for a quick reference. Next, in our processor file where we last extracted the class name and package name, we are going to create utility methods like private methods for generating each of the files. For example, we will have one method for generating our DAO implementation. Now, this DAO implementation needs to know about the fields because we will be converting those student object in our generated DTO. Next, we will need to know the class name and package name in each of our utility methods since we'll be creating multiple of those. So what we can do is we can create a private members at a class level, and then instead of making it local, we can use the class level one. This way class name and package name is accessible. Optionally, you can pass these fields also to this method. Next, we'll start creating a string. So essentially, we'll write our entire generic code into a string, and then at the end, we'll write this entire string into a file, which will contain our entire code. So we'll use a string builder because it is mutable, so you can change it. Instead, if you use a string and concatenate it, it is going to create a lot of internal objects. And then we'll start appending one at a time, one line at a time. So the first line here is about the package. So we can copy this, paste it here. Okay. Now to make it generic, we don't want to hard code this package name, correct? And anyways, we have extracted the package name at our class level. So what we can do is can remove this, and instead of the package name hard coded, we use the package name which we have at a class level. And then to finish it off, we're going to put a semicolon because we only have a package name, and then put a 2 new line characters. So we are also going to maintain all the formatting. So one new line character will get us to this line, and another new line character get us to this line. Next, we have to import these. So these are not going to change across all the DAO layers. So this is something that can be hard coded. So what we can do is we can simply write it as is with a new line character. So essentially, I'm going to skip this and get to the real logic here. So next, this guy you also understand. For this one, so I'm going to demonstrate this part. So you paste this guy here. Now see, the public class keyword is not going to change. Also, the DAO impl is not going to change. So we need to put our generic names, which is going to change depending on the model class name. So the way we can do it is public class, then a space, append this dot class name dot append DAO impl dot append, actually we can use it here, implements. Okay, and then again the name of our model class, which is a generic one. So again this dot class name dot append DAO, because we are going to suffix all our interfaces with DAO in curly braces \n, and that's it. That's the generic equivalent of this hard coded line. Again, I'm not going to walk through each of these lines, otherwise video will be too long. So what I'm going to demonstrate is some core logics here, and I'll link the source code in the description so you can go and check out the entire implementation for yourself. I'm just going to demonstrate how you can generalize all of these. I'll show you the quick challenges that you're going to encounter. For example, these exception classes. So you will have to put the throws keyword, right? Followed by these name of the exception class. You will also need them in your interface. So it's better to create a utility method for it, or a utility block of code. So in our generator class, what we can do is at the top, we can create a list, and then across different implementation to make it generic, we can continue to append the name of the class. So for example, if model class name is a student, then we can append a student to this and it will become a student request exception. If the model class name is employee, it will become employee request exception. And then wherever you need to generate that throws keyword, so what you can do is body dot append, you can do throws, and then you can do a for loop. Since we need to put commas in between, so what we can do is we can instead iterate using index, and then we do body dot append. So we are going to prefix it with a class name followed by the exception class dot get at I. Okay, and then we put a if condition. If I equals to exception dot size -1, that means we know it's a last element. So we'll put a reverse condition or negative condition, which is not, and we are going to append a comma followed by space. So this way we can generate our this string, which is throws string. Next, I think the biggest challenge that you're going to encounter in generalizing this aspect is putting in the unique key condition for delete and update methods. If you want throughout the code, you can put comment for your reference as well. So for example, logic to generate throws statement. Next, we're going to put logic to generate if conditions on unique key. So we'll start with if, and then we have a opening parentheses, and then we need to iterate through all the unique fields. So we are taking in this unique fields from here, so we can directly iterate through them. Now in here we need to check two things. If the field type or the data type of field is primitive, then we need to use equals to for comparison. But if it's non-primitive, then we are going to use dot equals method. For doing that, what we can do is we can call field dot as type dot get kind dot is primitive. So now with the know that it's a primitive, so what we can do is body dot append, and then logic to generate DTO name dot append dot get, and then we can do field dot get simple name, and then we do append the parentheses, and then equals to, and then append the comparison value. And don't worry, all these placeholder code, you can find the reference in the description box. I've linked the GitHub repository there. So this way you can find if it's primitive, you can add a logic to put equals to, and in the else part you can put that. Now you can also, in order to decide whether you want to put end condition, so you can again iterate using the normal for loop instead of for each, and then you can put a similar if condition that we have put during generation of throws statement to decide whether you want to put end or append end in the string or not. Now, assuming you are done with generating all your string, now you want to create a file for it. So the way to write the string would be to get a writer instance first, and for getting so you can use the processing n dot get filer dot, and then you can call create source file. And where do we want to create this source file? So you specify the full qualified name of the class that you're generating, including the package name. So we put class name, which is a student, and then we are going to append DAO-Wimple at the end of the name of the class. And then you call open writer. So you get a reference to to this file, to write into this file. Now this is going to throw IO exception, so we can catch it. And lastly, you can write the string and put body.toString, and in the end close this. Similarly, you can create multiple of these utility methods for each of the file, and then towards the end, firstly you can construct the string, and then towards the end you can write it. So that's it. We have our code generator with us. Let's create a project out of it. Before we jump into project creation, let's look at the distribution part. I'm going to demonstrate using Maven, but you can search for the process across different tools if you're using Gradle or if you're using command line. The process remains the same. Firstly, I've completed the FileDB generator class, which you can find in, or FileDB processor class, which you can file in GitHub. Next, what you need to do is in Maven, you will get a resource folder. Within that, create a meta INF and a services folder. In that, create a file and name it javax.annotation.processing.processor. And within this file, put the name of your processor class, and it should be a fully qualified name. Just click on install. Now you have this installed. What ambient install does is it will create a jar and it will put it into a local Maven repository. Next, what you need to do is create a new project. Create a model class student. We can add field, roll number, name, percentage. You can generate the getters and setters. Now we are going to mark it as FileDB generated. We are going to put roll number as a unique key, persisted, and the name also will keep persisted. So now only thing that you need to do is rebuild the project. Now as soon as you rebuild the project, our FileDB generator processor will be invoked during compilation, and then all of these files will be auto-generated. So what I have done here is in the main method, firstly I'm calling DAO.getAll. It will print an empty list given we have not added even a single item to our DB yet. Next, we are going to add 4 student objects with roll number 1, 2, 3, 4 using our DAOs add method. Then if we print, if we call DAO.getAll and print all these student objects, we'll see all these 4 objects getting printed on the screen. Next, what I've done is I've changed the name of S1 object to Sam from John, and when I call update and then call all the objects, then we must see that the roll number 1 must now reflect Sam name. And next we are deleting the S1 object, so when now we call get all and print object, we must not see the Sam object or the student with roll number 1 at all. Let's run it. Alright, so on the output, as we can see, firstly, since the list was empty, so nothing was printed out. Then we added these 4 objects, and when we print it all, we can see all 4 are persisted in DB. When we updated roll number 1 from John to Sam, so we can see it is reflected here. The rest of the objects remain same. Next, in delete, since we have deleted the object with roll number 1, so our database only contains 3 entries. And if you want, there is this student DB file generated as well. Of course, it is bytecode, so it is not much readable, but we can see it does got created when we run this project. So what are the next steps from here? I've just introduced you to a new area of project creation which can greatly enhance your resume. It can potentially give rise to innovative concepts, much like next Lombok, Google Juice, or even Spring Boot. It's a low effort, high impact project that can truly make a difference. So keep coming up with innovative ideas. And when you do, Don't forget to tag me or reach out to me. I'll be more than happy to give a shout out. If you are interested in contributing to the existing code base that we just created as part of this series, feel free to send the pull request. I'll link the GitHub repository in the description. I hope you found this series of video helpful. If you did, please like and share it with your fellow coders. Thank you so much.